See my screen now. Can everyone see my
Yes.
screen?
Yes, we can see your screen.
Yes, we can see your screen.
All right. Okay. Good morning, everyone. My name is Oluyele Sunday Anthony, and I will be speaking on how to build a machine learning model from scratch. So these are the outlines we are going to be seeing of this machine learning applications, some of the steps in training, and how to implement using Python, and finally the conclusion. So going into what is machine learning, we are going to be starting with what is machine learning. So machine learning is the process of making systems that learn and improve by themselves by being specifically programmed. The ultimate goal of machine learning is to design algorithms that help a system gather data and use that data to learn more. So what we are saying is actually we are trying to create a system that actually behave like the way the human being behave. That is the way our brain is. Whatever we are doing as a human being, whatever we have been doing has been a function of whatever we have seen or whatever we have come in contact with before. Like that is what is called data. Like if you, as someone that is a human being, if you can recognize anything, if you can make decisions based on anything, it is going to be based on whatever you have come in contact with before. And those are the data that has been stored in your brain, and you're making you are trying to make decisions based on those data. So that is what we are trying to model with machine learning. Machine learning just is a way to make computers behave like human being. That's the way the brain actually works. So systems are expected to look for patterns in the data collected and use them to make vital decisions for themselves. So what we are saying is that with those data that are given to this computer are supposed to look for things that are close, things that can be connected together to make future prediction, to make so that is what machine learning is all about. And looking at machine learning in general, we said we want them to look to behave like human, and this can make them to make some certain to perform some certain tasks, like separating spam from actual emails. As in Gmail, you just discover that some mails in your Gmail automatically goes to the spam folder, and you're wondering why is this thing happening? It has been passed through some algorithms that has been able to make your email to know definitely that this particular mail is supposed to be in the spam folder, that it is containing some form of some form of maybe some form of scam or anything. So it can also some of the tasks also include correcting grammar and spelling mistakes as seen in autocorrect. These are the jobs of machine learning model. So we can also use them in real world to make object and image recognition, to detect fake news, understanding written or spoken words, both on websites that interact with humans, like human self-driving cars. We have many applications of machine learning in our real world. You just discover the machine learning are also used to create something like recommender systems. For instance, if you go to your Netflix, if you go to some of your if you go to YouTube Netflix and all that, you just discover that they start giving you some form of recommendations. And if you use some apps like Jumia, you just discover that they start giving to you some of your interests, and you be like, how did these people know that I am going to buy a shoe? How do these people know I was supposed to watch a movie like this? Those are the kind of jobs this machine learning model has been able to help us automate and be able to do. You see some of the image recognition systems whereby you just see that your your apps and all that are able to detect that this particular person is, you just see on your Google Photos, you just discover that there's a way your Google Photos just try to perform some form of image recognition and be able to separate some people that you have automatically in your Google Photos, and be able to detect, okay, this person appears in this picture, this person appears in this picture. These are jobs of some of this machine learning model. And today we are going to be seeing how we can build our own custom machine learning model from scratch. So going into creating our own machine learning model, actually in the world of data science, we'll discover that we have a lot of buzzwords, a lot of words. We think this thing might be very too big. Like when we hear machine learning, for instance, we think that, okay, this thing is going to be something that is very, very difficult. This thing is going to be something very gigantic, and I don't think it is something that I can do. But by getting deep and getting close to what this particular thing is, you discover that these are just simple concepts that we just need to get ourselves familiarized with. Like what we said about machine learning is just a way to model the way our brain functions. So to create our own machine learning model is not something that is very, very big, though there are some things that we have to do that requires a bit of some technicalities. But look, if we are going through this particular presentation, you discover that there are just some things we need to get ourselves familiar with. So first thing we need to do is to collect data that we are going to be using for a problem. For every problem we are going to be solving, definitely we need data. I explained initially that even our brain needs data to work, to function. There is no way a newborn baby that was born today will just know that a color is black, a color is green, a color is yellow. It needs, the baby actually needs to be told that this particular color is, and that's why we go to school to learn. So, and we'll actually get to the part where we train our data. That is where our machine learning actually learn just like us. So, and part of the first thing we need to do is to collect data. If we are trying to predict, maybe we are trying to predict, maybe in a machine in an object detection context, before we can be able to detect that this particular thing is a ball, this particular thing is a cat, this thing is a dog, this animal is this or that, we need to give it data that it is going to use. Maybe, for instance, you are trying to predict prices of houses. Maybe due to some attributes, maybe you want to know, okay, for houses with 4 bedrooms, for houses with that are around Lekki, for houses that with some attributes, we need to collect known data that we know that are verifiable to be able to train this model for better prediction. So as you are seeing, machine initially learn from the data that we give to them. It is of the utmost importance to collect reliable data so that your machine learning model can find correct patterns. The quality of the data that you feed to the machine will determine how accurate your model is. If you have incorrect or outdated data, you will have wrong outcomes or prediction which are not relevant. So what we are saying is this: if let's say you are working for a firm, maybe a biotechnological firm, and you need to create a model that actually predicts maybe diabetes or maybe heart disease or whatever, something medical. You know that this particular thing are actually things that are crucial and critical. If you go and make mistake and you do not collect data that are relevant, you know the way all these diseases and sicknesses work. Some of these things they change, they are mutable with time, and you do not collect. Maybe you went and collect data of maybe 1990 something, and you discover that some of the things that applies then do not apply now, and you are trying to make use of the data, holding this data that do not really work this day. You're trying to make use of it. Now you discover that the kind of model, the kind of prediction you're going to be making, even though your predictions might be telling you that you have an accurate model, but you discover that when they try to apply it in real sense, in real cases, it might not, you might be sacked eventually. So what we are saying is collecting, not just collecting anyhow data, but collecting data that are very, very efficient and very relevant to what we're trying to do. You don't want to try to build a model that recognizes a dog, and you're trying to collect data that only has cat in it. You know that you are making a very, very big mistake. So the next thing is preparing the data. So why oftentimes when you are trying to collect your data, there are lots of things you need to do about the data. You don't just feed in the data to the model and you expect to get prediction. And this is where the job of a data scientist really come in place. You need to prepare the data. If you are trying to predict, you're trying to do a form of object recognition or image recognition or something, or facial recognition, you need to label the data properly. If you are doing maybe some form of regression analysis, maybe you are trying to look for patterns and something about maybe trying to predict price of commodities or something, you need to be able to streamline the data to know, to be able to tell the model, because a lot of machine learning models, they don't just work by just feeding anyhow data. Some of those data need to be converted into numerical values. Maybe you are collecting data about categorical values. You need to be able to do some form of cleaning to the data, removing unwanted data. There are some that will just come with missing values. There are some that even the attributes you collected are not in line with what you are doing. You need to remove them. You need to visualize the data and look for some form of correlation, some form of things that are kind of related in the data you have collected. And there are a lot of things you need to do. You need to clean the data. You need to visualize the data to understand how well this data are structured. You need to see some relationship between this data, and that is where you need to do some lot of works. So also one of the things that normally used to be done is splitting the data. You need to be able to create some form of training set and testing data to overfitting and underfitting a model. There are tons of model that is available under in machine learning. We have lots of model. We have linear regression. We have logistic regression. We have some. It actually depends on the kind of problem you are trying to solve. You can be solving problem about classification. Maybe you are trying to detect, if this thing is blue, or if this thing is black, if this thing is white, or this thing is black. That's a form of classification model. But sometimes you might be trying to predict price of something, maybe based on the initial prices you have, the initial data you have. So you need to know the kind of model that will be very much suitable for your machine learning model. So he said a machine learning model determines the output you get after running a machine learning algorithm on the collector. It is important to choose a model which is relevant to the task at hand. So you cannot expect to use the same model you use for predicting price for image recognition. It won't work. So we need to know the kind of data that is suitable for the kind of problem we are trying to solve. So the next thing is actually training the model. So training the model is one of the most important steps in machine learning. In training, you pass the prepared data to your machine learning model to find patterns and make predictions. It results in the model learning from the data so that it can accomplish the task. Over time, with the training, the model gets better at predicting. So this is actually the part where the model is trying to learn from the data. So this is like going to school. You're actually getting data. You have processed the data. This is where you are making the model find patterns in the data you have given to it so that it will be suitable for prediction. So the next one is actually evaluating the model. So what do we mean by evaluating the model? Because you can just build a model that might not be useful for what you are trying to do. The other time I spoke about testing and training. This is the part where you try to like find maybe the accuracy of the model, find the precision of the model, find a lot of things about the model and see how efficient this particular model is. So we said after training, you have to check to see how it's performing. Like let's say for instance, you have built a model and your model, you know that you have given it, maybe you are trying to predict the prices of houses in a particular location, maybe Lagos. And this part of evaluation, maybe you are trying to try to predict maybe a 4-bedroom flat in Lekki, and your model is giving you that you are going to be paying maybe 50,000 naira for that house in Lekki. You know that definitely you have built something that is not accurate. So you know that definitely, because houses around that side will definitely be very, very expensive. So this is the part you check to see how your model is actually performing, and there are some lot of metrics we use in evaluating the model. We have things like precision, things like F1 score, things like accuracy and all that. So the next thing is parameter tuning. So maybe let's say we have been able to train, we have been able to evaluate, and we discover that what we have been able to train, the model we have trained, is really not performing well. So there's a way we can actually tune our model with parameters such that we can be able to get better prediction and maybe better accuracy of the model we are working on. Let's say we are using one of the machine learning model. Maybe we are using a linear regression, for instance. A linear regression, if we are conversant with mathematics, is about fitting a particular model, fitting a particular data to a straight line. Like it obeys the law of straight line, y equals to mx plus c. And you just discover that by just trying to tune some of the parameters, for instance, if we are doing models like, we are creating models like random forest, we can be able to like give some parameters to it to just check for better accuracy of the model. So this is done by tuning the parameter present in the model. Parameters are the variables in the model that the programmer generally decides. So a particular value of your parameter, the accuracy will be at the maximum. Parameter tuning refers to finding this value. So you are trying to look for the particular point for your model to be at the maximum accuracy. And the last step there is making prediction. So this is the part whereby you're actually making prediction based on your model. So let's look at how to implement these steps using Python. So the first step there is actually importing necessary library. We need to import pandas for manipulation of those data. We need to use import some libraries like the label encoder for pre-processing, the train test split, the linear regression model that we'll be using, and a metric that will be used for evaluation. So this is the part, this second part is actually the part where we are trying to import the data we want to use for a model. Like we see this part, read CSV. So we're actually importing an insurance.csv file for our data. And after importing that file, we see that this is the visualization of the file. We see we have the age, the sex, the body mass index, the children, the smoke, whether the person is a smoker or not, the region, and the charges. So we are trying to build a model, a linear regression model that is going to predict insurance charges based on some of the information that is given by people. So if you look at this particular file we have here, we see that it has 1,338 rows. That is, there are 1,338 records data that is going to be used for this prediction. That is, whatever this model is going to be predicting will be based on some of this data that has been given already to the model, and it's going to look for patterns and it's going to look for patterns based on this model based on this data that it has. We see that the other time we talked about pre-processing, there's no way our model is going to understand female, male, and some of these whether yes or no, southwest, southeast. So that is why we need to kind of pre-process the data, and that is what this label encoder is going to do for us. And it's going to, in a way, transform our categorical data into numerical data. This part is going to remove duplicates and so many pre-processing steps that we have there. So this part is trying to like split the data into training and testing data, such that we'll be able to test our model using the testing data. So the next step, after the pre-processing, we will see that this the data has already been cleaned, and some of the female, male has been changed to 0, 1, 1, where 0 represents female and 1 represents male, and the region also has been converted to numerical data. That was done using the label encoder. So after then, we choose the model we are going to use. We use the linear regression model. It's a model that uses the equation of a line, y equals to mx plus c. So, and we fit the data into the model, and we actually perform the training using that fit, this linear.model.fit. That was where the training actually happened. So the next line is actually when the prediction is done. So we're actually predicting using our test data. And this last line here is actually the accuracy of the model. We see that the model is actually 100% efficiency, 100% accuracy. So this part is parameter of the model. We see the coefficients for age and all that. We can try to like fine tune. Since we have a good model that has actually predicted very well, there is no point trying to like tune the parameter. So that's all for the steps. So in conclusion, we can see that machine learning is an enormous area. It is empowering technology for allowing us to develop software solutions much faster than before. And currently, the state-of-the-art solution for a wide range of problems. We can apply it to almost every domain. It can be used in the health industry. It can be used in a lot of things, in marketing. They even use it in and even use it for prediction in schools, whereby you can know whether someone is going to pass an exam or not, based on some parameters that are going to be given to the data. And that will be all for my presentation. Thank you very much. If you have any questions, we can ask.
Thank you so much, Sunday, for the brilliant presentation. I think it has sent a question on the chat. I don't know if she wants to talk or.
Yes, so I'm talking. I don't really understand this thing well, but just answer this one. What's the difference between machine learning and then AI? They sound similar to me, so I don't know. Help me out, please.
All right. So machine learning is actually artificial intelligence is actually the mother of all of them. It actually encompasses all of them. Under machine learning, under artificial intelligence, we now have subsets like the machine learning. We have some others like deep learning. We have computer vision, and a lot of them. So AI is just the mother of all these things we are talking about. So that is where under it we have machine learning and some other AI stuff that are related to it. So you cannot really remove one from the other. They are actually under each other.
Thank you. That helps me.
Any other question?
Sunday, if they don't have questions, please ask them questions.
All right. So let me just see the question I can ask. So we talked about parameter tuning during the presentation. So can somebody just explain what parameter tuning is during one of those steps we talked about? Thank you. Anybody can just.
If no one is talking, please call anybody.
Okay. Mr. Israel.
Hello.
Yes, sir.
Yeah, actually, parameter tuning, I think, is how I put it. Now, is that you correct some data on the machine learning? So that's how I see. That's why I understand it.
All right. We're actually close to the answer. Parameter tuning is actually trying to like look for that sweet spot for our data for our model to actually perform the optimally, like the best accuracy we can get from our training. So that's just what it is.
That was what was in my head.
All right. Let me just ask one more question. So what are the somebody just give us one or two applications of machine learning? One or two applications.
You teach us that one.
Should I go to the that was like the
answer the question. So answer the question. Direct it to
I literally just say he did not teach us that one. Application of machine learning.
It doesn't have to teach you what application of machine learning is. It's in every aspect of life.
No, it's not in digital marketing, sir.
There was a time I spoke about.
It's not.
Hello.
Okay.
One of the applications is text image recognition.
Yes.
And text translation.
Yes, you're very correct, sir. So that was when there was a time I talked about spam, trying to like separate spam from normal emails. So those are some of those applications. I talked about heart disease prediction, diabetes prediction, and some of those things. And I talked about recommender systems like our Netflix. They will just bring up some stuff that are what we are actually interested in. Like you see your Jumia, they just bring shoes for you, and you're like, how do these people know that I want to buy shoes? So these are some of the applications of machine learning. Thank you.
Just a question, please, a quick one. I wanted to ask, don't they use AI in the hospital, or is there no?
What do you say?
Is there no medical application of AI or machine learning?
I actually spoke about, when you.
I'm just trying to make I'm just trying to clarify this thing.
Okay. I spoke about heart disease prediction, for instance, and there are also some they actually use it in all these ultrascan, whatever, trying to predict whether maybe a kind of blood cell or something. These are the application of image recognition systems. They will go to the lab, they will scan some maybe white blood cell or some form of scanning, and they will look for patterns that actually that has a particular disease in it, and they will use to make prediction that okay, it's likely this person has this particular disease due to the fact that there are some patterns in this particular scan that has what is not supposed to have. So it is actually present in almost every sector and every field.
Sorry, Mani, I want to ask one question. This data, this thing, is it SPSS that is used for the result or what?
Is it what?
Is it SPSS that we used to?
Now, this we have data analysts and we have data scientists. If you're talking about data analysts, a data analyst actually try to like look for visualizations based on data. And one of those tools you can use for analyzing data is that SPSS. I think SPSS is a statistical package. You actually use it for all these statistics, all these just to visualize data. But when I talk about a data scientist also need to visualize the data to know the relationship between this data and also perform some make some that is where you see parameter tuning, training, and all that. You cannot use SPSS for training your data. You understand? You cannot use all these visual. You can only use SPSS for visualizing your data and look for patterns, but you cannot use it for training. And that is why we are making use of Python for this machine learning training and all that. I hope you understand.
Okay, thank you.
Yeah, Sunday, you've actually presented well. Thank you very much. Yeah.
Thank you. It was wonderful.
So if there is no other question, I don't think Peter Monday is here. So I would like to bring the KD section to an end. Yeah, I hope to see everybody on Monday. And I'm correct, also to clarify something, there is KD on Saturday. I don't know if I've ever informed you that. So if you are scheduled on Saturday, you're supposed to. Yes, it's not compulsory for people to join, but if you are scheduled, you're supposed to present. Yeah. So, yeah, or maybe you missed and you want to refix. I can also put on a Saturday for you too. Okay. Yeah. Thank you, everyone. Wish everybody a lovely working day.
Thank you, sir.
Yeah, you too, sir.